Hey guys, welcome back. So we're going to be finding the ideal gas law constant in this experiment. And we're going to talk about the ideal gas law and the rules that go along with that as the first part of test 3. But since this is finding that constant, that's actually a dimensional analysis problem. So this is the best place in the schedule for this to go. So let's take a look at this experiment. I want to show you one particular part of this to make sure that we're clear on what needs to happen. So I have already come in here and answered some questions and gotten this set up. And I have some data that I have collected. So I calculated the mass of magnesium, the moles of magnesium, the temperature of water, the temperature of the water in Kelvin, the vapor pressure of the water, and the barometric pressure. Okay, so and I've got the urometer all set up. I think that's how you said it. All set up, so it's ready to go. So I currently have my stopper with the magnesium hanging off of it here, and I need to invert this. I've already put the HCl and the water in it, so I need to invert it. And so I'm going to go ahead and invert this. And then I need to zoom in and make some observations. And I can see as the magnesium gets smaller, I form hydrogen gas. Okay, so that's my observation. I have to let this go for a little bit. Hooray, hooray, hooray. Now that it's done, I can zoom out. And it says, at the reaction's completion, equalize liquid heights. Zoom in on odometer and use up-down arrow to raise or lower it. So I'm going to zoom in. And what I need to do, if you can see this, there's a water line in the beaker up here. So I need to take and move this up so that the water line comes down and the meniscus moves up. So I'm going to keep going, 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 keep going. And when I get right about there, I see that the meniscus and the water line are exactly the same. And this is 18 milliliters. Remember, this is upside down. So 17, 17.5, 18. So I opened my lab data and I put 18.0 milliliters. I can convert that to liters, 0.018. The pressure of the hydrogen gas, okay, is going to be that 771. The pressure of the hydrogen gas is 751.184, and that is the 771 subtract the 19.8, which is the water pressure. So that's 751.2. And so I put that right there, 751.2. And then I have to convert that to atmospheres. I'll let you find that conversion, 0.988. And then the moles of hydrogen gas are based on the moles of magnesium that were consumed. 0.0774. Now, I need to calculate the ideal gas constant. And what it says is that the ideal gas constant has units of liters times atmospheres over moles times Kelvin. So I take my, I take my liters times the atmospheres divided by the number of moles and divided by the temperature in Kelvin. Okay, and so when I do that, I end up with a value of 0.08. And for sig figs, what? Sorry, wanted another sig fig, another digit. And so pressure of hydrogen gas, 0.88 9884. Sig fig there. And that's what it's looking for. Okay, so this is simply a unit conversion. And once you've done that, you'll be able to go through the phase. Now, if this is wrong, if you put this in, you put in like 17.8, right? It'll say verify your measurement, and it'll tell you either raise or lower. So you'll know which way to go so that it's level. And keep doing it until it stops complaining. That's really what it comes down to. You should be fine with that. And remember that this pressure is this barometric pressure minus the vapor pressure when you got to that point where it's even. Okay, so that is the case. All right, so that's what you're looking for. 0.00, and it wants 2 decimal places. And that should take you through everything. Hopefully that'll take care of what you're looking for. All right, that is solving for the ideal gas law constant. Okay, and so we use the pressure that we've measured in the odometer, the number of moles that were produced, the volume of that, and then the temperature in Kelvin for what that was, and that gives us the values that we're looking for. Okay, so this is really just a dimensional analysis problem. You should be able to handle this, but I set this due date for the 11th, which is after we will have covered this material. So there you go. Thanks, guys. I'll talk to you soon.